You're listening to Made for IoT, a podcast celebrating the leaders, innovators, and disruptors of the Internet of Things, from hardware to connectivity to cloud. For more insights, make sure you visit onomondo.com.
Hello, everyone. Welcome to today's webinar. My name is Thijs. I'm part of the growth team at Onomondo. Today, we're going to talk about IoT device efficiency, where we'll be taking the kind of the connectivity angle and combining two quite unique perspectives from both the antenna and kind of the network side of things. For this webinar, Onomondo, a cellular connectivity provider, has partnered up with Ignion, an antenna innovator. And for that, we have Johan and Peter here, Peter from Onomondo and Johan from Ignion. Before I hand it over to the experts to talk about this topic, I just want to say that we have a chat function also in this webinar, and I will be keeping an eye on the chat. And if you have any questions, just send them over in the chat, and we'll try to answer them in this webinar. If it doesn't work, we'll make sure to answer your questions afterwards. Maybe Johan, do you want to start off with a short introduction of yourself and Ignion?
Sure. Hi, everyone. Thank you for joining our webinar today. I come from Ignion, who is the company behind the virtual antenna technology. You see us being the red parts on a lot of IoT devices out there. Actually, more than 30 million IoT devices today use the virtual antenna technology. And we thought that it would be interesting to bring the perspectives of how to optimize your device efficiency when making IoT devices from the point of both the antenna and the network side, because both play a huge role, both interact, but both are rarely in the same room. So today we are going to go through a few real life examples and a few tips and tricks from both sides. Overall, the uniqueness of Ignion and our technology is that it is very simple and easy to get a robust performance in your IoT devices. Antennas is typically a hard thing to get right, and there is little expertise in the market. So we are bringing tools and building blocks to make that a lot easier. I will elaborate a little bit more on that later. But an example of where you see Ignion and the virtual antenna is, for example, on the Thingy 91 platform from Nordic. So this is a small prototyping platform for asset tracking. And there you see the red antenna up on the top. I think I will sort of leave it at that and let you, Peter, introduce yourself.
Yeah, cool. I'm Peter, work as a developer here at Onomondo. My current project is actually a soft SIM that we are launching on the Nordic device as well. After that, don't know. Let's just move on. We'll get started.
All righty. Let's go to the next slide. So overall, when you're looking at deploying a new IoT solution, you've gotten this great idea of making the world a better place, and you need to know about something going on somewhere. There you need data to arrive from a device to the cloud somewhere. And overall, this world is becoming increasingly more complex, both when you see it from the antenna side, but also when you see it from the network and connectivity side. So on the local device level, you're seeing that there is more and more connectivity standards, and within specific standards, there's more and more bands and wireless frequencies to cater or to worry about. The devices are becoming a lot smaller, and more and more devices are battery operated. This means that the devices themselves are more constrained. When you're running on a battery, you don't have a lot of power budget to do a lot of things. So you need to be really smart about how both you design the device and also how you plan the connectivity options. And typically what we see is that the typical design cycle of IoT devices, a lot of designers, they start with the wireless modules and the hardware piece. Often the antenna is left too late in the game to be able to really optimize it. So first tip, make sure to consider the antenna in the beginning of your hardware design. But then on the connectivity side, your options and your choices there might also affect the hardware. So another tip is to also consider in parallel what connectivity options you're going to use. And Peter, he will elaborate a little bit more on that because both have an influence on the actual hardware design. And once the hardware is hardened, it's difficult to change things or at least costly. Things like wireless certifications obviously also play a role, and that's where it's important to consider those things early to make sure that you don't lose the launch dates of your planned IoT device deployments. So here on the slide, you see a graphic. This is from ABI research highlighting the complex world of IoT today. Overall, they will only get more and more complex. That is for sure. There's so much more innovation ongoing. And meanwhile, that is fantastic. We both at Ignion and as well as at Onomondo are focused on simplifying this journey for IoT device makers. So we thought it would be interesting to look at a few concrete examples. Before jumping into that, Peter, is there anything you want to add here?
No, I think you're pretty spot on. Like this figure is very antenna centric, but when it boils down to like what it's actually about, then it's about reducing complexity and overall increasing the efficiency. And Onomondo as a company, we have built some pretty powerful tools that addresses exactly these points. So I feel like the antenna and the network operator goes hand in hand in this case.
Yes. Yes.
Yeah. And then you talked about picking a network operator or network technology early in the game. I think we're going to see here throughout the webinar that some of the tools we bring on board is really, really handy for development as well. So we have a case where someone is trying to mimic bad signal quality and yada, yada. But what we can do with Onomondo is you can kind of track all of these things remotely. So if you want to look at the traffic flowing to and from every single one of your devices, we can allow you to do that. If you have a device that's having troubles, you can actually deep dive into the signaling and trying to identify why that's happening. And these kind of tools are really, really good for development as well, as it gives you real-time insights instead of you having to ask your operator for this kind of data.
Awesome.
All right.
Okay, let's move into the real-life cases. So we've picked two major topics that we wanted to cover today. We want to dive into sort of the local environment and a few thoughts around that, and then move to sort of like the global operation. Both of our companies are working with a lot of customers, in particularly, for example, in asset tracking, where you typically have some kind of cellular connection that goes on some network. And at the same time, they are often small and placed in difficult locations. So let's dive a little bit into a few of those examples. So Peter?
Yep, sure. So the first example I've brought is a case study from a trash waste management solution, making some smart waste bins, aiming always to facilitate and optimize. And one of the problems they were facing, or the challenges, let's say that, is like the smart bins are located deep within buildings. You have no control of where they're deployed. Maybe it's in a concrete bathroom, we don't know. Of course, as we covered in the introduction, they are aiming to make this even lower power, more efficient, and as usual, you want to cut cost. So you're also working on a very constrained device. One of the issues they were facing during both development and after deployment were they had no insight into the network and signal quality. And they actually had issues with already deployed devices. So in the good old days, they would try to simulate this kind of bad coverage by putting their devices inside a made-up DIY Faraday cage and kind of simulate these bad behaviors and try to figure out, are we dropping packets? Is it a loss? Is it a signaling problem between device and operator, or where's the issue? And so the first thing we could offer was this real-time insight, but not just for a test device or 2 test devices. We could offer this kind of insight for the whole fleet. So an already deployed fleet, even in an already deployed fleet, you can kind of dive into problem as they show up. And another thing they wanted to address was the power efficiency of the device. So when you're establishing a secure connection over TLS, for instance, there's a lot of overhead in establishing the connection. So the TLS handshake is actually quite a lot of data going back and forth. And what we see as well is the TLS stack on a Linux computer is not a problem. It's all in the OS and you get everything for free and you don't think about resources. But once you go into super, super low power constrained devices, the RAM consumption is actually quite significant. So by using one of our technologies, the Onomondo connectors, where we kind of can remove this overhead from the device and put it into the network, they saw that they could save 25% of the available resources or RAM. And while doing that, they are also reducing the data transmission by over 30%. And the data transmission and power goes hand in hand. So that's really a massive battery and efficiency gain here. Guess we have some more numbers on this. Yeah, so connectors, it's all about reducing the complexity. And we are reducing complexity by moving all of that stuff into the network core instead. So we're taking the cloud connectivity logic, the SDKs that would usually be on a device, and we are actually handling all of that on our end. That means that you can just use your regular TCP or UDP stack and send the data to us, and we'll kind of catch on and then handle it for you. So I ran a little test using one of the Nordic NRF 9160 development kits. So what we see on the right-hand side, we have this is measuring the current or the overall power. We can see on the right, there are 2 graphs, and one of them is way longer. And if we look at the overall power, then we have to kind of integrate under the curve and that kind of stuff. But we can see that the sample where we use connectors, we could finish this drastically faster. When we had to set up the TLS handshake, there was a lot of data going back and forth. So in the connector case, we could maybe send 100 bytes, and that would be our temperature readings and maybe a status message. With the SDK on the device, we had to do a TLS session with Azure. This was then additionally done over MQTT, and then like the overall overhead were thousands of kilobytes, not thousands of kilobytes, thousands of bytes, sorry. And so, yeah, it's pretty cool. And yeah, just the left-hand side is a case study from Asian Mobility, where we saw they did some like kind of third-party testing for us or evaluation, and they saw an average decrease of 30% in data as well.
Quick question, Peter. So when you're moving some of this logic out of the device, does that then mean that you lose some like local functionality?
No, we're really trying to not mess around, or we don't want to impose anything. So actually, we're trying to free up your device to do even more. So you have fewer resources used on the device, and we're not relying on some special protocols or anything. It's still just standard IP. So you get all the benefits of the power efficiency while reducing the data. All right, I think we can move on to you, Johan.
Yeah. So I bring here a container tracker customer example. So it's a company called CIMC. It's a very, very large container company out of China. They have these ventilator asset trackers that needs global operation on LTM combined with GNSS for the locationing. And they're operating in more than 200 countries worldwide. So this is truly a global device. So a key challenge when you are developing such a global device is obviously you need to comply with and being able to communicate in a lot of different wireless bands. This is particularly tricky when you are need to cover some of the low frequency bands, so it's in the 600 and 700 megahertz area, where to get a high device efficiency in a small package is challenging. But by using the virtual antenna technology, they were able to squeeze out and optimize the design in a very easy manner. That is one of the main values of the virtual antenna technology, that by using the whole device size, the ground plane is actually, when you're using the virtual antenna technology, it is the ground plane that becomes the resonator. This means that you can basically leverage the full device size as your structure, meaning that you can really optimize the RF performance compared to other wireless technologies. Meanwhile, it being extremely flexible, that you can easily tune it to whatever frequency that you need. And in this case, it was for the global LTE-M bands. And then when you design an asset tracker that goes on containers, typically they sit very close to metal. And as you probably can guess, metal and RF are not the best friends. They're actually very bad friends. So let me talk a little bit about when you put an antenna close to different materials, because this is something that we see a lot. That in reality, these IoT devices, that they do get placed on things. They are not just placed in free air, right? So the wireless performance that you are seeing in the lab and when you're building the device will be affected by the environment in the surroundings. And we have a long expertise on making sure that our customers can mitigate those effects. And we've done a lot of different studies on the influence of different materials. And I bring here a few tips for you. So the study that you're seeing here is with wood, concrete, a body phantom, and metal. There's a little link down below in the slide that is a link to the study and our design guide for asset tracking that sort of explains these effects. But when we start with the first graph on the left side, where we have placed the IoT device close to wood, then we have taken the device with the antenna and we have placed it directly on the wood, and then we have varied the distance from 0 to 20 millimeters distance. So the graph, the green and the red curves you see there are how is the antenna efficiency depending on the different distances. The green one is representing the LTE signal and the LTE bands, and the red one is representing the GNSS band for the locationing. And as you can see for the wood case, in general, the signal, the antenna efficiency is not affected a lot. So overall, it's okay to place your device close to wood. You will still be able to achieve more or less the same performance. This could, for example, be for an asset tracker on wood pallets. We see a lot of those projects, and they don't need to worry about being very close to the material. If we then move to the concrete example, concrete does affect the wireless performance. However, just by keeping a little bit of distance, you see a huge improvement. So the short tip here is just make sure to keep some distance, and then you will be fine. If you place it just up against, then you will see degradation in the wireless performance. And to put it in context, the antenna efficiency has a direct influence on the battery lifetime of a device. If you take an example of an asset tracker, such as the one I showed earlier, the Nordic Thingy 91 platform, if you take this device and you transmit 1,000 bytes per hour, Nordic has this cool tool called the LTE Power Profiler online, where you can calculate exactly the power budgets. So if I take one transmission every hour in the asset tracking example, then the power budget going for communication will be 10 times more than the power budget for just the idle sleep mode of the device. So this means that what defines the battery lifetime of my device is the communication. When it's communicating, if you have 60% efficiency on the antenna or 30% efficiency on the antenna, has a huge influence. So if you're first in the lab planning on, let's say 8 years battery lifetime, without taking into consideration the antenna efficiency, and suddenly you place it up against a material that degrades the efficiency a lot, then you can suddenly see years of degradation in the lifetime of the device. If we place the device close to the body, the skin of either an animal or a human or a fitness tracker, it could be many different types of devices, but placed close to a human skin, there's also a significant influence here. And here actually there's a huge variation depending on where on the body of the human or the animal that it's placed. So here we typically work with the customers to find the best placement, and also while also keeping some distance. And then the last one with the examples of the containers on metal, things really get affected. And this is just physics. RF signals and metal do not play well together. So there are two things here. Keeping distance is critical. You should not have it close up against. And as the metal influence will detune the antenna systems, the powerful thing about the virtual antenna technology is that you can easily retune it. You can use the same antenna, and just by changing a few passive matching network components, you can retune the antenna system to be optimized for that particular environment, which is a quite cool feature of the virtual antenna technology. All right.
Johan, one question is coming in on the chat from Simon about this slide specifically. So what he basically asks is, what about NB-IoT? Is the antenna performance comparable in regards of the influence of the material?
Yeah. So what I'm talking about here is the antenna performance in various frequency bands. LTM and narrowband IoT are using the same frequency bands. So actually, this platform for Nordic can run both LTM and narrowband IoT using the same antenna. It is essentially the same case for narrowband IoT.
Yeah, and then one more question by Cepiso. He's basically asking whether you guys also conducted some tests on glass. Is that something you did?
Yeah, so on glass, that is not a part of this study, but I would love to do one and hear more about his case. We don't see as big an influence from glass in general. We have a lot of different automotive telematic projects and such and so forth. But I would love to hear more about the specific project.
Great, thanks.
All right. Good. I think we can then move on to the more global scenario. So all of these devices, many of them live in a global world. So let's dive into a few concrete examples from the global operations side. So I'll let Peter start with some SIM steering topics, and then I will talk a little bit about the orientation of your devices.
Cool. Thanks. Yeah, so the next case study is mobility as a service. It's again Asia mobility, and some of the challenges they have or requirements they have is that they need as robust a connection as ever possible. So they are operating in very rural areas, in general, on a more global level than what we've been looking at previously. And yet again, they want to optimize data efficiency, and that's also, as usual, a very important concept. So we have had these. Asia Mobility has been comparing us to various operators to see how well we could compare in terms of both efficiency, but also in general with overall signal quality and the amount of network disconnects, for instance. So what we saw, which is a little bit surprising, is the SIM has a lot of influence on how well the measured signal quality is. And it's not because the SIM will work as an antenna or anything like that. It has a way more simple reason, and then it is that the SIM will kind of steer towards one network instead of just allowing all possible networks to be used by the device. So during this test, we saw that even though the same networks were available with Onomondo SIM cards, we allowed the device or the modem to pick whatever network it liked. And we saw an average signal quality that was significantly better overall. They were also counting the disconnect events and how many times I actually completely lost network connectivity. And then again, we saw that even though we have like technically the same networks, it is on the same vehicle, driving the same route on the same day. Everything is the same. We still saw a pretty significant difference between other operators and Onomondo global SIM cards. And the reason for this is actually something called SIM steering. And it's something that most providers do, and it's done through what's called the PLMN list, which is the Public Land Mobile Network list, which is on a SIM card. And this list is typically based on commercial agreements and not on how to optimize the signal quality or anything like that. So it's this kind of list has to be obeyed by the modem. So once you turn on your device, if we look at the left figure, we see that there is a priority for the home network, and that signal tower or antenna is really, really far away and has a pretty poor connectivity, but it's still technically within reach. So your device has to pick your home network. End of story. And this also applies to countries, not your home country, visiting countries, sorry. So I think we've all tried it on our cell phone. Traveling to the US is something where connectivity can be a bit spotty. We also know that the market there is a little bit weird in some cases. So what you typically see is that on your phone, you have basically no coverage at all. You cannot even access Google or open Google Maps and try to find home. But your friend is like heavily streaming Netflix and full signal. And that's actually due to this preferred network list on the SIM. And so the preferred network list on the SIM is designed to kind of minimize cost for the operators and maximize their profit. And so at Onomondo, we have the freedom to choose whatever network we have because we're not really making money on the data. So as a customer or user of Onomondo SIMs, you just pick whatever network that suits you, or maybe you just allow all networks in a country. And that opens up for this scenario too. So in the standards, 3GPP standards, it says that if there's no home network, check, we don't have that. If there's no priority list, we also don't have that. The modem should pick a random network with high signal quality. if there is no network with super high signal quality, it should just rank them and pick the first one with the highest signal quality, basically. So it is directly in the standards. If you don't put this list on, your modem will automatically pick the network with the highest signal strength. And so the previous results we saw before was mostly due to this thing. When they were driving in this rural area with very spotty coverage, the Onomondo SIM could switch between operators way more than these steered SIMs could. And so the overall signal quality and overall performance were way better. And this directly translates into this efficiency thing as well, where if you have a really poor connection, you will spend a lot of power transmitting the same amount of bytes as you would do on a network with really good signal conditions. So I think it's quite interesting how much the SIM can influence it, even though the SIM is just like a really, really dumb device. So it's a file system, and it kind of opens this list, and it has to obey this list, kind of.
We have a few interesting questions coming in, Peter. Which signal quality indicators do you use to switch between different operators? Is that RSSI?
So I think it's important to stress out that we don't do anything of that. So it's implementation specific on the modem, but it's typically the received signal strength, I guess.
Another question by Will. Do you see that other network providers, through their commercial agreements, prioritize networks through the POMN list, even when roaming, not in their home country?
Yeah, definitely. So typically you will have like a cheap network in the roaming country, and you will have a more expensive network. So of course you order the network, so your device will prioritize the cheaper agreement. And so if you have a flat data rate or a flat data plan, you say 10 gigs in the US, of course your operator will earn way more if they get to prioritize the low-cost network at all costs, basically.
Final question on this slide by Tepiso. If you say not steering is the best, how is the selection criteria based on from the POMN list? Is it coverage or signal strength or resilience? And does QoS affect steering in any way?
Yeah, so the network selection is focused around the received signal. So whatever the modem deems the best network, it's free to choose. And that's actually the only thing we steer. So yeah, quality of service affects steering in a way? No, not that I will think, at least.
Interesting. Let's continue and come back to some of the other questions we'll be handling at the end of this webinar.
All righty. Then so it's interesting. So if you increase the efficiency on where to connect to, taking the shortest route communication wise, meanwhile you have optimized your antenna to ensure that there's efficiency basically on both sides, giving that longer battery lifetime. The next topic I would like to highlight is then how do you orient your device? Because when deploying these IoT devices, typically you don't know how they will be mounted in which direction. And I have a couple of examples here. So this is the thin track. It's a device this size. It's 8 times 3 centimeters and 3 millimeters thick. It's a tracker that can be used to track parcels or even letters of high value. Because it's so small, you can simply slit it in an envelope. And it comes from this company. It's developed by a company called Samia. It is a development house, design house here in Europe. We have worked together with them on enabling the robust RF performance, covering both the cellular, GNSS, Wi-Fi, and Bluetooth in that same really small device. So obviously, this is a lot of wireless bands in a very little space. but because of the flexibility of the virtual antenna technology, it was possible to deliver a robust connectivity in the different scenarios that this device will end up in. There's one antenna covering the cellular and GNSS piece, and then another antenna covering the Wi-Fi and Bluetooth. So the Wi-Fi and Bluetooth is used for more local positioning and also smartphone interaction, where the cellular and the GNSS is used for the overall tracking. A key thing that influences the battery life on this piece, as it's so small, there's a tiny battery in there, right? So everything counts. So you want to have high efficiency on the antenna, and you want to ensure that the battery lives long. Another factor that's important to consider is the GNSS. So when you're using GNSS or GPS, you're connecting to a satellite for the locationing, or multiple satellites. And a key factor for the power consumption here is the time to first fix. So that is the time it takes for a device to have the first reliable connection with the satellite. The longer the time to first fix is, the longer time the GNSS radio needs to be on. And these GNSS radios typically use around, let's say, 40 milliamps when they're active. So they are very power hungry. So this means that you want to limit the time as much as possible to ensure that it lives on, have multi-year battery lifetime. A thing to consider here is the type of antenna used for the GNSS. And I'm highlighting the difference between two antennas that are very commonly used in asset tracking devices for GNSS today. One is the virtual antenna technology, which are the red parts you see on here. And another one is the patch antenna. The key difference to note here is that the patch antenna is what we call circular polarized, and the virtual antenna components is what we call linearly polarized. What this means is that the patch antenna is directional. It means that it performs better in one direction than another. So if you mount your device flat and the satellite is on top, you get great performance and great connectivity. However, if you turn it around and so the antenna is facing the ground, then you see significant decrease in the performance, which is obvious that it is designed to have this directional behavior, whereas the virtual antenna technology has an omnidirectional radiation pattern. This means that whatever direction you orient it in, it has the same efficiency and the same robust connection. Now, if you are out in the country, open fields, not a lot of reflections, then the patch antenna and the sort of the directional performance, given that you are orienting it in the right direction, it will give a good performance. And the virtual antenna with the omnidirectional pattern will give more or less the same. So they are more or less the same time to first fix. Now, when you then move into urban environments and cities where there's buildings and a lot of different reflections, then suddenly the directionality becomes a problem. And in particular, if you have mounted the device in a suboptimal orientation. And we have made a large study on this. It is published in a scientific paper I'm also linking to here, where you can see all of the data and all of the results. But just in short, the conclusion is that when you take the average of typical environments and usages where asset tracker devices are deployed. The linearly polarized, the virtual antenna technology has a lower time to first fix than the typically used patch antenna. And this is important because, as I mentioned, these devices, the GNSS power consumption is 40 milliamps. So just by reducing the time to first fix, you get even not only better connection and making sure that you have the good location, but in particular the longer battery life. And I invite you to check out the technical study. If you want a less technical, I also here put a link for a blog post where we explain those in more human kind of details.
One question, very interesting. One question coming in on the chat from Alessandro. What about accuracy in the positioning and multipath rejection when talking about linear versus circular?
Yeah, so the accuracy in the location is basically depending on how many satellites you get connection to, and it's if you have a more robust connection, then you can get connected to more satellites and thus more accurate. On the second part, I would need to come back to you.
Yeah. Great.
Cool.
All right. So I think time-wise, we can sort of round it off. We have covered a few examples from the network side, how to increase efficiency by using the connectors and taking the shortest route by not doing the SIM steering. Mm-hmm. And we've talked about the local devices that you need to consider what they are placed against. And also when you're deploying the device, that the orientation also has an influence. If you're using patch antennas, whereas you can choose technologies like the ones from Ignion to make sure that you don't need to worry about that. So we have a few tips to get started on this. So from Ignion's side, we have designed this guide that takes you through all the key considerations you need to worry about when you're building cellular IoT devices, focused on asset tracking, but basically this design guide is for any cellular IoT device where you can see the influence of the PCB device size, you can see the influence of being close to different materials, you can see the influence in the time to first fix, and sort of get a good idea of what to be able to expect and the key tips on being successful there. And then on the right side, I'm highlighting our Antenna Intelligence Cloud Design Tool. So this is our tool where you can build your free digital prototype of your new IoT device and the antenna system in there. So basically, in a matter of minutes, you just fill in a little form saying like, hey, I'm building a narrowband IoT device. It is 5 by 10 centimeters large. And then in a matter of a couple of minutes, you get a report and a custom design file for your device. So you can do your feasibility digitally in the cloud without needing to build any hardware. And then from those results and design files, you can easily copy and paste that into your Gerber PCB design tool and get started in a fast way on a robust RF solution. So please go in and try it. There's a QR code here that you can scan, or you can also click in the webinar system. There should be a link for it as well. So you can go in and try it out today and see, just give it a test, see what this tool can, how this tool can help you. It's totally free of charge.
Great.
Right. And Peter?
Yeah. Same as Ignion. If you want to get started and it's free, you can also sign up with Onomondo on our webpage. There should be a link as well in the call to action. What you get with the free trial is the remote debug capabilities. You get full trace end to end. If you want to test the Onomondo Live, Onomondo Traffic Monitor, you can capture traces from all of your devices, look at the data, are we dropping packets, all of that. If you have issues with your connectivity and the device gets kicked off, you can see if it's network related, if it's Onomondo sending a request for you to be kicked off. That would be weird, but it happens in some cases. But you get these full traces and a lot more. You get ability to test the connectors, and then you get a non-steered SIM card. Actually, you get a handful of them. All right. Time for some questions, perhaps?
Yes. Thanks, Johan. Thanks, Peter. Very insightful. If I may say so myself. There's a bunch of questions that have come in, and I think I'm pretty sure we're not gonna make it like be able to answer all questions, but let's just touch on a few of them. I think two questions came in around this, Johan, and it's a bit more specific towards Ignion specifically. The question is around kind of the ground plane of the product. So when you say you can use the full ground plane of the product when using a virtual antenna, is this referring to the full square surface area of the PCB, or only the portion of the ground plane directly in line with the antenna?
Yeah. So I don't. Maybe you can make our videos a little bigger, Thijs, then I can show. So here I have a bare PCB example. Up here, the first centimeter is the clearance area. That's where we tell customers do not put any components in the clearance area. The antenna is in itself is non-resonant, and we also call them antenna boosters. And what they do is that they ignite the whole ground plane. So it's not only the clearance, but it's actually the whole ground plane that gets utilized. However, in the lower frequency bands, if you have a larger clearance, you get typically better performance. So there's always a balance between how large the device and the wireless performance. And that is where our cloud solution, where you can build your digital prototype, is fantastic, because you can go in and play around with these factors and see the influence almost immediately.
Thanks for that. It's tying a little bit into it. Vladimir also asked whether you can comment on the size of the ground planes for the lower frequencies while using a virtual antenna. Yeah.
So in general, the virtual antenna technology is relying on physics as any other antenna technology. What we just do is that we optimize. So when you are talking about the low frequency bands and in cellular IoT, the Thingy 91 platform that I showed earlier, that is like 5 by 5 centimeters, that is like pushing the limits. Meaning that if you want to go smaller than that, then typically what we see customers, they do more regional variants, because to have a global operating device covering a lot of frequency bands also in the lower range, then you cannot go much lower than 5 by 5 or 5 by 3 centimeters. Then you will get, and you need to certify the device. That will be difficult. So typically we advise customers to make sure that you don't just go as small as possible to begin with. Ask your team, hey, can we maybe add a centimeter or two? Because this means a lot for your low frequency performance.
That makes sense.
Vladimir just commented also, that is exactly what I do with a smiley face. So that's
all right. Good.
Peter, on the network side of things, there's also a few questions. Let's take two before we kind of round off today's webinar.
Yes. Sure.
Which IMSIs is the SIM using? Is it a global one?
No. So it's just a regular Onomondo specific IMSI, and just to reiterate that the SIMs are single IMSI as well, so it's not a EUICC we offer, but a regular UICC.
And then you touched on kind of the SIM steering. Then a question came in. The argument for non-steering SIMs is certainly a strong one. What do you think the counter argument might be from a network provider who doesn't work in this way, such as one of the big players who actually have the lists, actually work with those lists? Do you have an idea of that?
There are some cases where the initial attach will be quicker since you have given it a priority. So as soon as it sees one of the priority networks, it can start attaching. The initial attach with an unsteered SIM will typically be a little bit longer, but after that, your SIM and your modem will work together to kind of remember the last good known network, and you will get similar performance.
Great. I think should we round it up here? We have some additional questions, but they go a little bit from some of the topics that we've discussed to more around kind of Ignion's offering and Onomondo's offering, which is probably we'll make sure we follow up on those questions after the webinar. Also, there's a lot of people expressed that they were very happy with this webinar. That's great to hear. There were also a few questions whether there would be a recording and whether the slides will be shared. I will make sure to share recording and the slides also in a way that the links that also Johan referred to, that those links are clickable, so you can kind of go into that. Yeah, thanks for today, Johan, Peter. Any finishing note?
No, thank you both. Thank you all for joining. This was a little bit of an odd combination. Typically, we're not connectivity antenna in the same room, but I'm happy that there were so many people joining and good questions. So maybe we'll do something again in the future.
Yeah, who knows?
Sounds like a great idea.
You've been listening to Made for IoT. Never miss another episode by following us wherever you get your podcasts. For full transcripts and slides, visit the link in the show notes or onomondo.com.